everyone. Today we are going to talk about relating the gravitational acceleration, the small capital letter of G, on the surface of the Earth to universal gravitational constant G, the big G, the capital letter of G. So how do we relate universal gravitational constant to the gravitational acceleration? For this topic, we are going to talk about the acceleration, calculating the acceleration. All the object will fall to the ground because we have gravitational acceleration. So we use the formula F equal to mg. According to the Newton's second law of motion, all the objects on Earth will fall. So our formula is F equal to mg. Okay, now we are moving on. If the object is up on the surface of the Earth, so we are going to relate these two formulas into this one. So mg equal to gmm over r squared. We have to cancel the same variables, so it becomes gravitational acceleration equal to gm over r squared. So we are going to use this formula to calculate the gravitational acceleration. Okay, let's look at a question. Calculate the gravitational acceleration of an object with the mass of 50 kg above the surface of the Earth. Given that the mass of the Earth is 5.97 times 10 power of 24 kg and the radius of the Earth is 6.37 times 10 power of 6 meter. So how are we going to calculate the acceleration? So we just have to plug in the formula. M equal to the mass of the Earth. Okay, the mass of the Earth is 5.97 times 10 power of 24. R, which is the radius of the Earth, is 6.37 times 10 power of 6 meter. The gravitational pull, which is the universal gravitational constant, the capital letter G, equal to 6.67 times 10 power of negative 11 Newton meter square per kilogram square. So to calculate the gravitational acceleration, we have to use the formula gm over r squared. Okay, just plug in all the numbers. Equal to the big capital letter G is 6.67 times 10 power of negative 11, and the mass of the Earth is 5.97 times 10 power of 24 divided by the radius of the Earth, which is 6.37 times 10 power of 6, and then we have to square up the radius, equivalent to 9.81 meter per second square. So acceleration, you have to be careful with the unit, which is meter per second square. If it is a gravitational constant, or we have to find the gravitational force, we have to use Newton. But this one, to find the acceleration, we have to be using meter per second square. Okay, thank you.